through the receptacle and back to the panel to save you from an electric shock. Now, let's say you're outside with no shoes on and the ground or the soil is moist. If you touch a hot wire, you could complete the circuit and the current may pass through you to get back to the supply. In this case, the resistance is going to be very high, so the current might not be high enough to automatically flip the breaker and cut the power. This will likely lead to the person's death. Luckily, we have the GFCI receptacle or the GFCI breaker. GFCI stands for Ground Fault Circuit Interrupter. We're going to look at a circuit breaker version, but essentially they're going to work the same. This GFCI breaker is going to be connected to both the hot and the neutral of the circuit, so we can monitor the wires and ensure that the current running in the hot wire of the circuit is equal to the current running in the neutral wire of the circuit. If the current is not equal in these two wires, then it's clearly flowing back to the source via another route. We then have a ground fault. The breaker will realize this and very quickly and automatically flip to cut the power and kill the circuit. Connected to the main panel, we will find a thick copper wire which leads out to a ground rod. The ground rod is buried into the ground outside near the property.